All right, everything looks good. Yeah, so I don't know about you all, but the recent React announcements has me kind of feeling like this. So much power. It might be a little too much power. I don't know. We'll see. I have to show this video. This is not related to my talk. I tweeted this video recently, but I have an app that's like a heavy data grid app. I turned on the async mode or concurrent mode now, and so you get time slicing for free. You have to check this out. So it's all janky. When I'm pressing the button, it has to render the full grid. I switched out with it concurrent mode, 5 lines of code change, and it's just smooth as butter, right? So thank you React team. It's amazing. So we've talked a lot about what's great about React and what sucks about React and what they're doing about it. We haven't talked a whole lot about React Native, and I'm very invested into React Native. I think it's a really important piece of technology. So what sucks about React Native? I'm going to talk about something. I'm James Long. I do a bunch of React. I created Prettier, and I own my own. I own my own business, Shift Reset. All those logos always confuse me. So for the past 2 years, I've been helping a startup called Blink. It's a video messaging app with complex navigational logic. Has these fun videos that you can send to each other. You talk into it, and it transcribes, and fun video effects. This was built in React Native. The camera portion, there's a whole native layer that requires a lot of Swift code for the camera pipeline, but the UI is all React Native. So I learned a lot about complex stuff there. Another project I've been working on is Actual. It's a personal finance system. This is the desktop version. It's not quite released yet, so sign up at actualbudget.com. Obligatory marketing. This is the mobile app. This is really the reason that I'm giving this talk. Because you see, I started this app a few months ago. I had already had a bunch of experience with React Native, so I was already a little frustrated, to be honest. I went to implement a specific interaction on this screen, and I got stuck. Couldn't do it with React Native, and I got mad. So I wrote this talk. I'm going to be talking about interactions and why they're so important to get right in mobile. So interactions make computers either frustrating or delightful. I'm not entirely sure what I was going for on the right side of this slide. I'm not an artist. I guess it's like idea clouds, I don't know. Inside of these machines are really powerful things that you can do, though. But what makes these accessible is the interface, right? And not just what you see, but how you interact with them. How many of you use the 2-finger scroll to swipe up and down websites, right? I mean, everybody here, I'm sure, does that. This is everywhere now, but so how many of you actually remember when that didn't exist? OK, a decent amount of you. So, I guess it was like 2005, around that, before, I can't even remember if the MacBooks, they had a trackpad then, but at some point, there was a time when these really beautiful trackpads did not exist. And what we would do is we would use mice with actual physical scroll wheels that made this really loud, clicky noise. Oh, wait a second. There's actually one right here. I did not put that there. So yeah, this fun noise. Let me see if, yeah, that's fun. I'm sure thousands of live stream viewers were just janking off their headphones. With this kind of stuff, details really matter. You can't just do it without much thought. It's really frustrating when you're trying to do an animation. It's not quite following your finger. It's a little bit too slow. It's not really that big a deal in the grand scheme of things. But it's kind of like having a good picnic outside, sun is shining, but gnats, to keep biting you. Just kind of ruins the experience. So I don't know about Android, but iOS has set a really high bar for mobile interactions. The iOS APIs and the native languages make it really possible to build some really, really elegant interactive animations. And in my opinion, React Native must be able to match this level of excellence. Right now, there are a lot of strong incentives to use React Native. Just not having to write your app twice is a huge one. It's great. But in the end, I really think developers won't end up being satisfied if they can point to other native apps and say, I can't do that. I just don't think we can really sell this to companies, especially ones with current native development teams that are so used to these APIs and can build these rich animations. It's a hard sell sometimes. So when it comes to interactive animations, React Native has problems, and they tend to stem from the same issue, the asynchronous bridge. So this is the two different lands, iOS and JavaScript or React Native. For them to speak to each other, they have to send messages across the bridge, and it's an asynchronous bridge. So why is this such a big deal? Well, async is a virus. It infects everything it touches, and I hate it so much. You have this really nice synchronous system, easy to reason about, and then you need to use an API, and you're like, crap, okay, I need to make my function async. It's like, oh crap, now like these other functions called me, so I need to, it just kind of infects the whole system. How many of you remember before we had position fixed, right? Remember these user experiences? You're like trying to keep up with the on scroll by setting in JavaScript the position of the tab. It's a horrible experience. In this case, the browser is painting the page in a different thread than the scrolling happens, right? So scrolling in a browser is async. So there's literally nothing you can do. Like you're stuck. You're sick with async. But now it's kind of, there is a trade-off. There's actually legitimate reasons why the browser does scrolling async, because scrolling is an extremely important interaction, and it's just in browsers it's just way too easy to jank up the scroll. So there's a lot of trade-offs, and there's a lot of nuance. To understand it better, let's take a quick look at how computers paint what we see. Typically, apps target painting about 60 frames per second. This means you must finish within 16 milliseconds. But it's even a little bit more complicated than that. So here you're seeing actually the monitor refresh rate at 60 hertz. So at 60 hertz, a monitor is going to be actually changing physically the pixels on your screen every 16 milliseconds. OK, so let's assume that your app's rendering loop is synced up with that refresh rate, right? So your app's rendering loop is starting at the same time in sync with when the browser or when the monitor is refreshing. As long as you render within 16 milliseconds, you're fine. The minute that you have a frame that takes too long, you're over budget. So now you have a decision to make. Do I display that frame and just assume that I'm going to paint the next one on the next tick afterwards? Or do I try to paint within the next, if I have 8 milliseconds left, do I just drop that frame, try to paint within 8 milliseconds? I don't know. Or what happens if a touch interaction starts in between the browser or the monitor refresh? So the monitor has shown some pixels, 8 milliseconds go by, touch interaction starts. Do you try to paint within the 8 milliseconds, or do you just assume that's going to take 16 milliseconds to paint? There's a lot of little nuanced decisions here that usually the platform takes care of you, but you can still write code that is bad. An even worse example is if your app's display rate isn't synchronized. And so here the app's rendering loop is actually offset, so it's starting the rendering loop in between the monitor's refresh rate. And so here, the entire app is always rendering underneath 16 milliseconds. But because it's not synchronized with the monitor's refresh rate, you're still going to drop frames. And so here, that first frame was finished before the first refresh of the monitor, so it got painted to the screen. The second one took a little bit too long, even though it was under 16 milliseconds. It took too long, and so it missed that monitor refresh. And then the third one made it on the third one, so he dropped that second frame. So achieving 60 FPS just isn't the goal. I hear that a lot, and it's actually more complicated. Achieving consistent, reliable animations that are always synced with as much as possible with what's going on with interactions and with the monitor, that is the goal. OK. So animations can either be declarative or imperative. There's kind of like a gradient here. It's neither or. You can usually have a combination of some imperative and declarative code, but usually imperative animations are easy to express complicated things, easy to implement, and declarative animations tend to be easier to optimize. So you just pass it off to whatever platform is running it, and it can run it the best it possibly can. All right, so let's start diving into how React Native does animations. So let's start with the animated module. This is the built-in module that comes with React Native. You use it by you just create an animated value with 0, and then you can apply it to a view. So here, I'm creating the animated value. I apply it to the view with the transform property of translate x. And then I can start this animation by calling animated.timing and then .start. So I'm saying animate this value to the value of 225. And so here is what that very simple animation does, just moving the box over. So while I imperatively started the animation, while it's running, it's a declarative animation, right? I told the platform to just move the value to 225. I don't care how you do it. So this is a declarative animation for the most part. You tell a system what to animate to. This is usually preferred in a lot of ways because the platform can optimize it, make sure that it doesn't stall, make sure that it's fluid. In React Native, it's actually absolutely necessary. Let's take a look at another example why. This is the pan responder object. This is what you use to track interactions in React Native. So here we have, you pass a couple methods, like grant, move, and release. Grant is when the interaction starts, move is when the interaction moves, and release is when it stops. And then you apply it to the view. So here, with this, we can implement simple animation where we can, move a box around. And the code for that is here. You don't need to worry too much about all this code. The main thing that you need to look at is here in the gesture move event. We set the animated value to the gesture state of the Y translation. So that's not too bad. The other parts of the code are just to make subsequent animations right. So we need to actually know what the current value is of the translate Y, and then when you press it multiple times, that it just still is in sync with your finger. This code is a little bit weird, though. Why are we adding a listener to the animated value and tracking it locally? The reason is because animations happen on native side, and you're in JavaScript land, and so you literally don't have access to the value. To get access to that value, it would have to be an async API, but async API in this kind of animations, by the time you get it back, it's going to be out of date anyway. So the idiomatic way to do this is that you add a listener and you just track it locally. But who even knows if the value that you have locally is actually up to date and sync with the screen, right? Because you're already in this async world. Most likely it's going to be out of date by a frame or two. So whatever, that works, right? Ship it. Well, here's an example of it running. Two boxes. The left box is controlled by native land. It has a panhandler controlled by native, so it's fully native. That is our goal. We have to be in sync with native, right? The right box is controlled by the pan responder in the JavaScript world. So it, sort of works, right? I mean, sure, if you don't really care too much about this stuff, it's probably fine. But I'm going to take a risk here. I'm going to try to change my display. I thought there was a keystroke for this. It's not working. All right, mirror displays. I'm going to show you. Here's the video. This is my favorite thing, by the way. You just do a QuickTime screen recording of an animation. Not only can you just play it back, but you can just watch it, look at every single frame. It's amazing. I do this all the time. All right, so it's in sync, it's in sync, it's in sync. All right, it looks pretty good, right? Oh, holy crap. What the freak? Why? So obviously, you see that on the right box, controlled by React Native and JavaScript, it gets out of sync. And it's because it just stalls for that one frame, and it missed the deadline that it needed. So this is horrible. Might not look horrible here. Trust me, it is. When you start getting into really complex interactions, when things start lagging, it makes your app feel like it's made up of rubber bands instead of actual concrete. We want apps to be solid. We need to compete with native apps. OK. Phew, that actually worked. OK, so this is what's happening. The touch happens on native side. React Native invokes your JavaScript handler over the bridge. Of course, that's an async. It invokes it async. The JavaScript executes, and then we set the animated value, which incurs another async call, and then the view updates. So the problem really isn't JavaScript execution. JavaScript engines today are super, super fast. The big problem is that the bridge is async, that we're still depending on this async bridge, because there's always going to be this little delay. Even however fast, I don't even know what kind of micro queue React Native uses, there's always going to be a little bit of delay, but even worse, something can come in and just run something on your thread that you were about waiting for something really high priority to come in from the other thread, and stall you, so you can't receive the message because something else is running. So who knows when the view actually updates? It could be something really bad. So basically, this other jerk comes in, task 2, like, hey, I need to run something, and you're like, no, please, no, I'm about to get something that's really high priority, and it's like, whatever, I'm not gonna screw you. I'm gonna block you anyway. Well, meanwhile, the user is over here, moving their finger around, all these touch events are happening, and they're like, what the heck, why isn't the app responding? Yeah, it's a really bad user experience. What we really want to happen is as the user is moving their finger, as these interactions are happening, we're updating the view in sync with the interaction. Okay, so there are some solutions to this. I wanted to be really explicit, why async really is a big problem and why these are needed. One solution is we can use animated event. So we have this on pan responder move. Usually with these callbacks, we can also just give it an animated event, and this is sort of a declarative way of saying bind this interaction value to my animated value. So here I'm saying dy, bind dy of the gesture to translate y. And so I'm declaratively telling the system to track the gesture to translate y. Now, the current animation system in React Native by default always runs on the in the JavaScript world. So you actually need to pass this use native driver true flag for it to actually work. So now, theoretically, the entire interaction is happening on native land, and we won't have that lag, right? Oh, well, crap. Actually, it doesn't work. Another fun thing about the animated library is trying to figure out obscure errors and Googling them and trying to look through issues and try to figure out what the heck's going on. Problem is that pan responder is completely implemented JavaScript side, so it actually can't support the native driver. In order to get the similar demo working, I had to use a scroll view, and so here you can pass on scroll an animated event to it, use the use native driver flag. Now it's all completely native, and the difference is just huge. You can just see how much smoother it is. It's completely in sync. So now we're 100% declarative, right? In order to have perfectly fluid animations in React Native, you just have to do this. It's just a necessary thing because you never want to cross the async bridge. So you have this whole pipeline. The interaction starts. You might process the data, multiply it by some values, or do some kind of cool spring animation, and then update the view. You want this all to be on the native side and never across the bridge of death. So the way we get around this, we provide this declarative forms of everything and pass it on to native side. Okay, so we got around it sort of, right? Problem is that they're pretty limited, these animated values and use native driver flag. Pan responder always runs in the JavaScript thread. You can't animate any styles that affect layout, like width or height. It's limited to whatever just the declarative API, right? You can't just do a simple JavaScript function. Functions like measure are async. Oh man, I hate it. Just if you're trying to use measurable return layout properties in JavaScript world, so if you want to measure a view, but it's async. If you need to do it when you're starting an animation to measure the height or width of a view, you can't do it because it's async, and so it won't be timed properly with the interaction. Use native driver is just confusing because it only works with about half of the features. So a new library to help with these is React Native Gesture Handler, created by Christoph. Provides a new way to respond to interactions that fixes basically a lot of these problems. After experiencing problems with pan responder, finding this library, I just felt like this. It was just I went through a whole range of emotions, joy, a little bit of sadness that I'd wasted a lot of time. But it built on top of the current animation system it still uses animated.value and event, but it replaces things like pan responder and touchable opacity. It does this by providing these components, pan, tap, long press, you can do all these things. And it's a declarative API. So pan responder was an imperative API. Here, you can just use it as a component. And now you pass animated event into it, and you never have to worry about the use native driver flag. By default, it's always native. And so this is that pan interaction that will be in sync with what the native should be. Now, it gets a lot cooler. There are a few important props like active offset x and y and fail offset x and y, and this allows you to implement custom activation criteria. What is that? Well, if you pass this prop and say 50, it's going to say don't activate this handler until the user has moved down 50 pixels. So what this says is, if you look at this video. The user, you're moving around, right? The interaction, it's not moving the box, but once you move down far enough, then it activates, and then you can move around as much as you want. Once it activates, then it stays the handler for the entire interaction. And don't ask me why a cursor is on a mouse. It's weird. Or cursor is on a phone. But so you can also pass an array. So there's a range. So you can say if the user has moved up 50 pixels or down 50 pixels, and so you can do both sides. You can even wrap handlers, so you can have multiple handlers together. And this is what I really love about this library. It makes it super, super composable. Because now you can start having multiple handlers with multiple custom activation criteria. So you can say if the user moves their finger up 20 pixels and activate this outer handler, which is going to move the translate Y animated value. If they've moved if they move down, it's going to do translate. If they move up past 20, it's going to do scale. And so that's what this looks like right here. If they move down past 20, it moves the box. If you move up just a little bit, then it starts scaling the box. You do this all the time in complex mobile interactions. You can have up to usually 3 or 4 handlers on the same thing, and depending on what the user is doing, you activate different handlers. You do this all the time. So here's a sketch of basically what it does. The interaction starts on the box. There's this sort of middle area that it doesn't know what to do yet, but once you've moved into one of those areas, then it activates a handler. So there's an interesting, this middle state, like what is that state? There's actually a state with touches, which is that the interaction has started, but it doesn't know which handler it has activated yet. So this is Blink. I was able to implement a bottom sheet, which actually is pretty complicated, in Blink using React Native Gesture Handler. So notice when you bump into it, it scrolls up. When you swipe down, it drags the sheet. But there's a scroll view in here. So if you load a bunch of stuff and you want to scroll, then you should be able to interact with the scroll view, right? But if the scroll view hits the top, I want to drag the sheet down. So I scroll down into the scroll view. I can interact with the scroll view like normal. Once I hit the top, I can even do the momentum scrolling. The next interaction that I hit down drags the sheet down. There's actually a lot of really nuanced things going on here, and it looks easy, but it's not. React Native Gesture Handler was really great. I was able to I didn't have to drop down to any Swift code to do this, which is really great. So I love this library. It operates completely in native. The declarative API is amazing. I really haven't run into a use case where I haven't been able to do what I want to. So Christoph actually made another library too called React Native Reanimated because the gesture handler only solves the problem of binding interactions to your animated values. What if you want a more complicated pipeline to do like conditional stuff with those values? It provides APIs like cond, less than, greater than, equal, and or. So you can actually end up doing pretty complex things like this, like control flow type things. Like if the value is less than 100, then use the cond API, and it'll say set translate x to 0 if it's less than 100. If it's over 100, set translate x to 100. So this allows you to construct kind of arbitrary control flows, which is really powerful. 100% declarative, so it can compile it away to native, and it never needs to cross the bridge. Here's an example from the examples repo on the library. It gets kind of complicated. They have things like clocks, so you can check the custom state. I would like to say, like, Christoph does amazing work, and I think we both agree, though, that like this is starting to get kind of weird, right? Like, we now need to learn this whole new language that is all declarative so that you can do complicated stuff. I don't think that we need to go this far. I think that this starts to get a little too complicated, and the only reason why we have to do this is because of the async bridge. There are a lot of cases where this might be useful. There are a lot of cases where I think an imperative handler where we could just run arbitrary code would actually be better. So it's good because it runs completely on the native side. It's a much more powerful declarative interface, and they have things like clocks and arbitrary control flow. But like I said, I really don't think that 100% declarative animations should be the goal. It's actually, in my opinion, it's more of a symptom of the async virus. It would be great if we could have the ability to drop down into imperative code, and it would be nice for certain cases. For example, in iOS, you just have all of these APIs at your leisure. View.frame, view.bounds. You want the x position of a view. You just view frame to origin x. You can just read the value. I mean, you can't even do that in React Native. So views have coordinate systems, and so you can convert points between views. If you just want to read the scroll offset on a scroll view, you just say content offset.y. If you want to add a handler to the scroll view to fire synchronously, so handle scroll view pan will be fired synchronously as you're scrolling, and within the handler you can just set layout properties of other views. It's super easy. It even has this idea of like a model and a presentation layer. So the model layer represents all the properties without current animations in effect. The presentation layer does take animations into effect. So if you want the current animated value of y, you call layer.presentation frame.origin.y, and you'll get the current animated like status of it, which again is not possible in React Native right now. So I ran into problems, so I had to drop down into Swift, and so I started using all these wonderfully beautiful synchronous APIs. About this time, I tweeted, that glorious, glorious feeling of using native APIs after using React Native. It just really, again, I ran through the whole gamut of emotions. It's like, man, how did I waste so much time? Started questioning my relationship with React Native. So here's my actual mobile app as it stands. A lot of little interesting interactions here. You can open the summary view. You can still scroll. You can scroll down and bump into the summary view, and it actually bumps it down. If you bump far enough, it closes it. Completely synchronous, feels great. You can select an item, and it opens up, tries to be in sync with the keyboard as much as possible. You can interact with dismiss. This is my favorite one. If you open that, scroll up, you should be able to pull the scroll view down, right? Because you don't want to see any of the area beneath it. Yeah, I love that one. Oh, it feels so good. You can't do that with React Native. You could, purely in JavaScript with React Native, you would end up with lag. And like I said, it kind of makes your app feel like it's made of rubber bands and not actually concrete. So for what it's worth, this app is written in React Native. There's only, I had to drop down into Swift and kind of bypass some of the things, and as long as you're careful, you can kind of get around it. But it is great that you can drop down at this time, at least, which is great. I'm able to do most of the app in Swift, and there's only about 300 lines of Swift. So this is what it kind of looks like in Swift. You just set the views. So if I'm doing that behavior where I want to see where I've collided, to collide with the view as I'm scrolling, you have your scroll view. You can add a target to the pan gesture handler, so you handle scroll view pan will fire as you're scrolling. And that's just it's going to fire synchronously. So within that method, I can just do all these point calculations, see if the point is greater than another point, and then just set the transform. And it's completely synchronous. This is great code. As much as I don't like mutations, I think with animations, this is just totally straightforward code. I think it's way better than sort of a complicated declarative interface that you need. So I was talking to Jordan Walk about this recently, and we were talking about in the context of developing a React Native app. In production right now, we just can't run JavaScript on the main thread. But he said, I would recommend React Native people run JavaScript on the main thread. You need to feel the pain. Otherwise, it's like grabbing a hot stove on morphine. And what he means by that is on the main thread, there's a lot of critical stuff happening. The minute that it needs something from the JavaScript thread, it's like grabbing a hot running thread. It's going to burn you. So we can try to ignore the problem, just give ourselves shots of morphine, just be like, OK, we're going to just kind of bear it. But I think it's time we need to stop ignoring this problem, because this is actually a very serious problem with React Native. In fact, personally, I was a little concerned about the future of React Native because of this, because you run into things that you're just hitting walls that can't be worked around. And as native platforms just get more and more advanced, it's going to be more and more harder for React Native to keep up. So if only there was a project on the React Native team that was working on this, if only they actually took this seriously, was working on this and coming up with a really great solution for this. If only there was a project that is the reason why I submitted this talk. That would be amazing, right? Man, it's never going to happen. Actually, it turns out there is. There's a lot of great work within React Native. One thing that I'm most excited about is Fabric. Fabric is a rewrite of the UI management system, and it's powered by JSI. JavaScript interface is an interface that allows you to just call methods between native and JavaScript synchronously as if they're normal functions. It's amazing, right? So you can just call a method. You can have native and JavaScript on the same stack. It's great. So Fabric is now re-architecting the UI management part of React Native to take advantage of all of that and have much more tighter integration of the views. So imagine you could just do this, view.measure, right? Or imagine you could do this, scroll view.onScroll, do some layout stuff, and just set the properties. This might be possible. It's very early. I'm not going to speak for the React Native team, but they told me that things like this should be possible at some point. So iOS and React Native lands, they're all happy now. And Ram is going to talk more about this in the next talk, too. So in short, avoid async. It's horrible. Declarative APIs are great, but you always need an escape hatch. And Fabric is just going to be awesome. I think I'm actually more excited about it than hooks, to be honest. Thanks.